Greetings. So in the today's class under embedded programming, we see about the special function registers. So already we have studied about the RAM inside 8051, and we know that we have got special function registers and the general purpose RAM, the bit addressable area, and the banks inside the RAM. So coming to the special function registers, you can see in your slide you have an accumulators and the data pointer, the B register, ports, power control register, program status word, timer control registers, serial communication registers, and some timer registers. It is given already with a RAM address, and all these addresses are inbuilt, so these can be addressed either using the name or otherwise using a address. So SFR, it stands with a special function registers. It is located in the area from 80 to FF. So the upper part of your RAM, it's dedicated to the special function registers. So we know that we have a RAM of about 128 bytes of RAM, and the upper part of 80 to FF will be special function. This is used to control the applications. For example, if you are going for a serial communication, the serial communication device bits can be configured using SCOR and SBUF, and all these registers, and these are special function registers which is used to configure the serial communication. And similarly, in case of a timer, if you're using a timer, you'll be needing, or you need a TMOD register, TCON register, timer registers. So this will manage the ports, timer, serial communication, interrupts, and CPU operation. And coming to the CPU registers, it has got an accumulator which is termed as ACC. So this the results from the arithmetic logical operations will be stored in the accumulator. The operands that is needed for the arithmetic and logical operation will be saved in the accumulator, and all the intermediate results will be saved in the accumulator. You have another register which is called as a B register, which is again a special function register. This has got very much importance in multiplication and division, where all the instruction will make use of the B register. One data in the accumulator and one data in the B register is needed for the multiplication and division. Similarly, the result will be also saved in the B register. In case of multiplication, the upper 8 bit, for example 8 cross 8 multiplication will give you an answer of about 16 bit. So the lower 8 bit will be saved in the accumulator, the upper 8 bit will be stored in the B register. Similarly, in case of division, the quotient and the remainder will be saved in the accumulator as well as in the B register. So another part of a CPU register is a program status word. Already we have seen all this in the architecture. The program status word has got carry bit, overflow, flarity, and all these kinds of status which reflects the status of the answer present in the accumulator or of the result in the ALU. So based on which you have flip-flops which will be set and reset. So this is what is called as a program status word. And this also, the program status word has got some bank bits that is called as RS0 and RS1 register select bits, which to select the register banks. You have something which is called as a memory registers, and one register, what you have to remember, is a stack pointer which will be pointing to the top of the stack. And you have another register which is called as a data pointer. This is used to access the external memory and again the internal read-only memory. So this will be holding the address, or this will act as a pointer. So that's what is called as a data pointer. It points to the data in the external memory as well as the data in the internal read-only memory. It's mostly the data in the internal read-only memory is called as a lookup table. And you have the next registers which are called as the input output port registers. So here this is also some special function register: port 0, port 1, port 2, and port 3. So port 0 is a simple digital input output ports, as well as this will have an alternate function of address and the data bus. Port 1 is purely an input output port. Port 2, it will be acting as input output as well as higher order address. port 3 input output, as well as it has got many alternate functions like serial communication, interrupts, timers, and all kind of control signals. So we have the next kind of register which are called as the timer registers. Timer registers has got some registers like TMOD to select the mode, TCON to control the timers as well as the interrupt, and TH0 and TL0 which is related to the timer 0, TH1 and TL1 to hold the values of timer 1. TH0, TL0 is timer 0, as similarly TH1 and TL1 is timer 1. And you have the next registers called as a serial communication registers. So this serial communication registers will send the data bit by bit. For example, when you are transmitting the data from the register, that is from a parallel register, to a device which can communicate serially, so you need to have a parallel to serial shift register which will be converting all this parallel bits to serial. So it's simple digital circuits what you have studied, a parallel to serial shift register. So all the data will be transmitted through the serial communication pins. Similarly, the data also will be received through serial communication pin. So transmission and reception can happen. And similarly, you have some registers to accommodate this. One is called as a SCON, other one is a SBUF. SBUF is a register which can hold the data, that is when during transmission as well as during reception. SCON which will control the serial communication. Other than then you have a register which is called as a PCON, which is not shown here, but that is also related to the serial communication. So here the next comes the registers for interrupts. This is very important. You have more number of interrupts. All these can be enabled only through the interrupt enable register, and similarly this register will enable and disable the interrupt. Similarly, the priority also can be set through the IP register. So making the bits as 1, it will increase the priority, whereas when making the bit as 0, it will reduce the priority. You have the next control register which is called as power control register. So PCON will have some bits for serial communication too, that is for the baud rate control, and again this can control the power modes during idle state. And this is a summary that is given. You have some registers which is called as SFR on the left side, and the functions which is given in the right hand side. All these SFRs will have an inbuilt address. So that is what either it can you can use, one can use this kind of English like a word, or otherwise one can use the address in the instruction so that the processor can understand. So these are the some special function registers and the CPU registers which is available in 8051.